Good morning all. Today we're going to do statistics part 1 video for CBSE and ISE 11 standard. Now in our previous classes we have learned how to find average in different ways, isn't it? We have learned how to find the centered value from our given data. There was mean, there was median, there was mode, there was quartiles and everything. This year, we're going to learn how to find range, mean deviation about mean deviation about median, and standard deviation. Now, the data that was given, in your previous classes help us to find the average or the centered value. But in order to interpret the result in a better way, we should know how far these values are spread around the centered value. Now, therefore, we have a slightly advanced methods to find the centered value, or otherwise how far the given data is spread out around a centered value. So first one in this is range. Range is actually very simple. Maximum value on x minus the minimum value on x. The values, the data given there will be ungrouped data. You take the maximum out of that and minimum out of that. The maximum value minus minimum value, the maximum value minus minimum value is said to be the range value. Make sure that the given question is an ungrouped data type. If it's a discrete where x and f is given, you have to take the largest value in x, not in f. Okay. Now, the next important topic. So range, we won't get that many sums. But mean deviation about mean and mean deviation about median and standard deviation are most important topic in 11th. Just like we had mean, median and mode last year. Well, in order to do these methods smoothly, you should have an idea of how to find mean and median. I've already made videos for that and share the link of that video in the description box. So if you have any problem in finding mean or median, do watch that. Mean can be found in many ways based on the type of data. Likewise, median can also be found in many ways based on the type of data. So we first have to know the way to find mean and median. Only then we can start the mean deviation or median deviation. Mean deviation about mean or mean deviation about median. So here I'm going to explain you all the formulas that we are going to use here. First one is mean deviation about mean. Types of datas. Datas are broadly classified as ungrouped datas, discrete datas, class interval datas or continuous datas. Ungrouped means you only find some set of numbers without giving any assignment as x or f or something like that. Simply some datas are given. So that is said to be an ungrouped one. Where we find mean using sum of x divided by number of observations. Sigma x by n. Sigma means total. So total of x by n. This is called as a direct method to find mean or average. And in case if it is an ungrouped data type and you have found mean this way, then the next step that you need to do is to find the mean deviation about mean. In that case, the formula is summation of modulus of x minus x bar by n. So it is sigma absolute value of x minus x bar. Alright, divided by the number of observation. Now, in case if it is a discrete data where there is x and f given in the questions where x and f is given, then you find mean using sigma xi fi by sigma fi, which is again a direct method, or you can follow shortcut method. As I told you at the beginning, if you have any problem, watch that video once again. So once you know how to find mean using shortcut method, you have to step into the mean deviation, which is sigma f into x minus x bar by sigma f. So here there is no f, whereas here f will come. Sigma f into modulus of x minus x bar by sigma f. And in case if the data is class interval type, use step deviation method to find the mean, and then use the same formula to find the mean deviation about mean. So as I told you in the beginning, and I'm repeating over and over again, without knowing how to find mean, you cannot find mean deviation. So it is very important to know this method. And for boards where calculators are allowed, step deviation and shortcut method doesn't make much difference. Since calculators allowed, you'll be able to handle out. But boards where calculators are not allowed, I would insist you to learn shortcut and step deviation properly, because that will help you in a longer run when you do standard deviation also. So let's move to mean deviation about median next. So next we are going to find mean deviation about median. So datas are broadly divided into three types, just like the previous one, and this is the case for all methods. Ungrouped data, if n is odd, median is found by n plus 1 by 2th term. Remember to rearrange the data in ascending order. To find median, you have to rearrange the given data in ascending order and then count the number of datas. If it is odd, we use this formula. If it is even, we use this formula. So once you find median, next we step into mean deviation about median, wherein it is sigma absolute value of x minus m by n. X minus m, this is x minus m by n. M stands for median. So every x value will be subtracted from the median value, and the absolute value of that is considered. Total is taken and divided by the number of observations. So next is the discrete data. Under discrete data, you find median using the same method like you do it for the ungrouped data. And then we find the median deviation, which is sigma f into modulus of x minus m by sigma f. So when it's a discrete data or class interval data, the formula to find the mean deviation about mean and mean deviation about median was pretty much the same. Only thing is here m will come, there x bar will come. So sigma f into modulus of x minus m by sigma f for discrete as well as for class interval in case of median, and the same way sigma f into modulus of x minus x bar by sigma f in case of mean deviation about mean. All right. Now, standard deviation. Standard deviation is denoted by this sign. This is how we write standard deviation. The sigma, this sign is called as sigma. Standard deviation or otherwise sigma. Again, ungrouped data. Standard deviation can be found using mean method and using assumed mean method. Using mean method, use it only when calculator is allowed, and use assumed mean always whenever calculator is not allowed. So standard deviation using actual mean. That means we first find mean and then we step into standard deviation. Whereas standard deviation using assumed mean, we don't even find mean. We take the centered value in the given x as our assumed mean, as our a, and then we do d equal to x minus a here. Okay, let's see the formulas in detail now. Ungrouped data, root over x minus x bar the whole square by n. Root over x minus x bar the whole square by n. Whereas here, root over sigma d square by n. minus sigma d by n the whole square, where d stands for x minus a. Then if it's a discrete data, it is root over sigma x minus x bar the whole square by sigma f. And if it's a discrete data and you're adopting assumed mean method, then it is root over sigma ft square by sigma f minus sigma ft by sigma f the whole square. Class interval type, root over sigma x minus x bar the whole square by sigma f. In case if we are using direct method of finding mean, and we are using actual mean to find the standard deviation. Here if we are using assumed mean to find the mean, and we are using assumed mean method. So it's h into root over sigma fd square by sigma f minus sigma f by sigma fd by sigma f the whole square, where d is equal to x minus a by h. Okay, so here I'm going to start with mean deviation about mean using actual mean. Okay, so first I'm going to find the mean here. Mean is we all know if I'm going to find mean, I'm going to use sigma xi by sigma fi formula. So multiply x and f and make a column for fx, or you call it as fi xi, and here xi. So 10 into 4, 40, 34 in 30 into 24, 720, 50 into 28 is 1400, 70 into 16 is 1120, and 90 into 8 is 720. The total of this is 4000, and total of f is 80. Now let's find the mean first. To find mean, mean is simply x bar. X bar is equal to sigma fi xi by sigma fi, and therefore it's 4000 divided by 80. We get mean as 50. Now when mean is a whole number, it is easy to subtract. In case if mean is not a whole number, then it would be a little tough job. So here it is 50. So next I'm going to make a column called x minus x bar, absolute value of that, mod of x minus x bar. Now x is 10, 10 minus 50. So what is x bar here? X bar is 50. So 10 minus 50, 40, but it's modulus. So its absolute value of minus 40 is 40. So then 30 minus 50. So every x value will be subtracted from 50 and taken over here. So this is deviation. 10 minus 50 minus 40, modulus of minus 40 is 40. 30 minus 50 is minus 20, modulus of minus 20 is 20. So like that, 50 minus 50 is 0. Then we have again 20 and 40. So next we need to make a column which is sigma f into modulus of x minus 50. So every x value will get multiplied with this. Every f value will get multiplied with this. So 4 into 40, 24 into 20, 28 into 0, 16 into 20, 8 into 40, so on. Okay, 4 into 40, 24 into 20, 28 into 0, and so on. 4 into 40, 160, 24 into 20, 480, 0, and then what? 320, again 320. So you find the total of this. This is 1280. Now it is mean deviation about the mean. The formula is sigma f into modulus of x minus x bar by sigma f. So that means 1280 divided by 80, which is 16 times. So this is mean deviation about mean using direct mean, and again where we take absolute value of the function. So next is finding mean deviation about mean using under class interval type of data. Previously I did for discrete, and this one is class interval type, where we are finding mean deviation about mean. Now in order to find mean here, we need to find the mid value of the class interval, which means x column. So first let's find xi, which is midpoint of class intervals. So 0 plus 4 by 2, 4 plus 8 by 2, and so on. So you get that as 2, 6, 10, 14, 18. Mid value of the class interval. 0 plus 4 by 2, 8 plus 4 by 2, 8 plus 12 by 2. So 8 plus 12 is what? 20. 20 by 2 is 10. 4 plus 8 is what? 12. 12 by 2 is 6. 0 plus 4 is 4. 4 by 2 is 2. So x is the mid value of class intervals. After x, we need to fix the middle value, the centered value of x as our a, assumed mean. So I'm going to take this as a. So ui will be x minus a by c. Here I'm following step deviation method. ui equals x minus a by c. It can be by c or by h. Depends. Some books use h, some book use c. So it's the class width or class size. Now what is a? A according to the assumption is 10. So x minus 10 by h. Now 2 minus 10 by h. And what is h? H is the class size. So let me write this one more time. So ui equals to x minus a by h, and here a is 10, h is 4. So 2 minus 10, that is 2 minus 10 by 4. We get minus 2, we get minus 1, we get 0, we get 1, and we get 2. Now fi into ui. So that means f is multiplied with u. Each value of x is multiplied with u. So that means 4 into minus 2, 6 into minus 1, 8 into 0, and so on. 4 into minus 2 is minus 8, minus 6, 0, 5, and 4. We need to get the total of this and the total of this in order to find the mean. So the total of this is minus 5. The total of this is 25. And x bar mean is equal to a plus sigma fi ui by sigma fi into h. So that would be 10 minus 5 by 25 into 4. So we find mean as 9.2. Mean as 9.2. Now let's start the mean deviation process. So for that we need to make a column which is modulus of x minus x bar. X bar here is 9.2. So x minus 9.2. So every x value will be subtracted from 9.2 and the absolute value of that is taken. So 2 minus 9.2 minus 7.2, absolute value is 7.2. 6 minus 9.2, 3.2, absolute value, and so on for everything. 0.8, 4.8, and 8.8. The next column that we have to make is sigma f into modulus of x minus 9.2. So every x value with this column value will be multiplied with f. So 4 into 7.2, 6 into 3.2, and so on. So we get 28.8, 19.2, 6.4, 24.0, and 17.6. So the total of this is 96. So now the median deviation, the mean deviation about mean. MD on x bar equals sigma f into modulus of x minus x by sigma f. So that is 96 divided by 25, which works out to 3.84. So this is how we find mean deviation about mean. Now let's do the mean deviation about median types. We finished all types of mean deviation about mean, in which class interval type and discrete type models have been worked out, and I've also listed out all the formulas that connected to this topic. So in my next video I'll do mean deviation about median. Thank you.